Welcome to Ingesting Data at Scale into Elasticsearch with Apache Pulsar. I'm Timothy Span. I'm a developer advocate at Stream Native, and I've been talking a lot for the last couple of years about the flippin' stack, which is Flink, Pulsar, and NiFi, working with different tools. Today we could call it the flippin' stack and put an E in the middle there for Elasticsearch, which is awesome open source project that works well with everything we have here. The company I work for is Stream Native, founded by the original developers of Pulsar. And we like to help people get up to speed with Pulsar, get them supported, trained, consulting, managed cloud platform, all those sort of things, plus Flink SQL. Today I'm going to talk to you about using Pulsar as a stream buffer in front of Elasticsearch, share a little bit about data ingestion, get that data syncing into Elastic, and show you the end-to-end architecture in some demos. So first up, why would I use Apache Pulsar as that stream buffer? Well, there's a couple of features of this open source project that make it ideally suited to handling different workloads around streaming, logs, different kinds of ingest. One of them is, it sounds kind of, it might sound silly to you when I say unified messaging platform. What we mean is we support lots of different types of messaging, lots of different protocols. So you don't have to, replace all the old protocols you're used to. If you're using MQTT on some edge devices, using Kafka over here, using RabbitMQ over there, you can use Pulsar to do all those types of messaging with those native protocols, plus a bunch of others. Makes it easy to put all your messages in one place, scale out as big as you need to go. Guarantee never lose a message, very important. Very resilient architecture. It's cloud native with a separation between compute and storage and anything else. Completely isolated so things can go down. It's easy to scale out to multiple nodes and geo-replicate when one cluster is not going to do it. And when we say scalability, there's a number of large cloud vendors in China that are scaling out to unimaginable sizes with petabytes upon petabytes of data, hundreds upon hundreds of nodes, and they just scale as large as they need to be without any issues. So that's a great thing. And the scalability also applies to the amount of storage that you have because we have built-in tiered storage. So, you get past what you might want in your storage nodes, and you could just stream that out automatically to S3, Google Storage, HDFS, those sort of things. So let you scale out. What's nice is that storage isn't treated differently. You could still access all your messages. So I can go back to the earliest message that anyone's ever sent for all my 5 million topics and not have any problem there. One thing that makes that 5 million topics more manageable than you might think, if you're used to some of the other messaging systems, you go somewhere and you type, give me a list of all the topics, and you're sitting there 10 minutes scrolling through them all. With multi-tenancy, not just security, we have things set up where you send a tenant up, and maybe this is a company, maybe this is a business unit, an app, whatever that is. Underneath there, you create different namespaces. Underneath there, there's your topics. So you don't have to list a million topics. Just list those in, a namespace you care about. So you're not seeing everybody's topic. You don't have to have ridiculously long names or special naming conventions to make them unique. They're under their own tenant namespace. You can have normal names there, which is great. With that decoupled compute and storage, very easy to scale this out and not worry about the complexity of that and have that run on Kubernetes if you need to. Geo-replication, so you could synchronously or asynchronously send data wherever it needs to go without writing special code for that. And that's disaster recovery is one use, but also might be to federate your data to different environments, maybe different parts of the world, different availability zones, lots of reasons there. And we mentioned that infinite storage, very useful there. Now, when we talk of buffering before Elastic, what do we mean by buffering? There's different time intervals you might want. You might want a minute before it goes in. You might want it a size. Get me a meg's worth or 5 megs or a gig worth before I start sending it over. Manageable chunks. Get it in certain batches of records. Or you might not even want every record. Maybe every record that comes through doesn't have value by itself, or maybe an aggregate of summary or a sampling. You know, 5,000 messages come back in from a device I have running on the edge, but each record just says the same thing. So if I get 1,000 of those a second that all say running fine or give me the exact same value, do I need to send that to Elastic? Maybe I send that one value with a count. Maybe that's more valuable. Or maybe an aggregate over the last minute, 5 minutes, whatever. This sort of thing, where this tiny little device, do I want all my million devices sending me every message thousands of times a second? Maybe not. You have to think about that. We could also geo-replicate to aggregate between different environments, maybe roll up a whole data center, roll up a whole country, and then aggregate it that way. And may want to, like I mentioned, deduplicate. This data is all the same. Do I need to send that off for analytics? Probably not. Now, can we stream buffer everything? Yeah, we have the high throughput and the scalability to be able to get it as large as you need to go, regardless of how many sources are coming in. And this makes it great so we can buffer between different data producers that maybe you don't want them directly accessing your cluster, maybe for security, maybe for other reasons. Have Pulsar act as that universal buffer gateway. Just give you the data that's important, maybe normalize it, put it into one schema. Pulsar has got a built-in schema registry, supports protobuf, JSON, Avro, all the popular schemas. Again, reduce that load on Elasticsearch, can do the things that it does best, search through your data, give you great analytics, do all those add-ons you have. Don't have it just passing data around. That's not stream value for you. And also, this data that's coming to Elastic may need to go somewhere else. It's very common. So have everything go into Pulsar. Let Pulsar distribute it to 20 different sinks if you need to. Maybe you have other people subscribing to this data for applications, for queries, for your data lake, for your lake house, whatever store that may be, wherever that is in the world. Maybe that's for a partner. Let Pulsar do it. Here's a diagram that has way too many lines in it, but gives you an idea of some of the things coming in and out of Pulsar and some of the verbs that I apply to this. We got a ton of different things coming in, ton of different systems working with it. So I can have Spark apps running, Flink apps, NiFi, could have, Trino, SQL running somewhere, could have my own app. And, some data is going right out to tiered storage. Some's going to Scylla. Some's coming in from a SQL database, MQTT from all those little devices, all different types of files coming in. They come into different clouds, different availability zones. Let me sync them up. I don't need to run Elastic in 2 different clouds. Let Pulsar handle that. You run Elastic where you want, and we'll push it through one pipe so you could secure that one maximum and, just pay for one pipe coming in, and we'll handle all these funky data formats. We'll buffer it. Maybe we'll batch it. We'll route it to the right place. Maybe you have multiple different Elasticsearch clusters distributed around the world. Maybe they get different data. We'll route that for you, filter out what you want, aggregate it if you need to, enrich it with other sources of data that can be coming in from databases or may already be in Pulsar that have been sitting there for maybe past runs, different kinds of data. Makes it easy to enrich them. Replicate that data to different clusters and different systems. Again, remove the duplicates, decouple the sources in the sync. So if things change, you don't have to know about it. We just agree on a schema and send it on its way, and distribute the data where it needs to go, when it needs to get there, as clean as possible. So let's do some of that data ingest. And that could be logs, sensors, events, tons of different data. Regardless, we have a lot of different sources we support, and that could be other messaging systems, whether they're cloud native ones or ones you may have on premise. It's very easy to have a small Pulsar cluster, located in house, and then have that replicate up to maybe a larger one you have running in the cloud, or one you have running with cloud Stream Native's cloud. Make it easy for you, and we could pull in data with other tools like NiFi very easily, which is part of the flip stack. What's nice with Pulsar is it has a lot of connectivity, so I can get a lot done in this part of the stack. Now I can have a ton of connectors there, and these also include Kafka Connect connectors. And what's unique is support for different protocols. So I connect to your messaging system, I talk that messaging protocol. If I talk to Kafka, it's over Kafka. I talk to MQTT, that's that protocol. Well, Pulsar supports its own protocol, plus these ones listed, plus Rocket MQ, and plus more. Makes it pretty easy to get your data in and out. Don't have to use special libraries. Makes it very straightforward. We could also use functions, kind of like a trigger, to do some of that routing, transformation, filtering, aggregation, what have you. And then if you need to do some processing, I'll show you Flink and Spark, or we could also do it with Trino. Gives you lots of options there. Having those different protocols plug into Pulsar makes it very easy. Say you have an existing app, has something like MQTT, you don't have to worry about, changing the library, recompiling it. Just point that existing app to Pulsar over the MQTT port, and you're ready to go. What's nice is data comes in from MQTT, can come out as WebSockets, can come out through Pulsar, come out through Kafka, come out through a sync. Doesn't have to come in and out the same protocol, doesn't have to come in and out the same format, the same type of data. You can have one topic come in, get routed to multiple, and you could do that pretty easily. Let's get some syncing data. So we got to get data in and out of Pulsar. I showed you a couple different ways. Well, very nicely, there is a Elasticsearch sync connector built into Pulsar. You start that up with some simple configuration, and I'll share a GitHub. That's been enhanced recently with bulk index support and schema support, so we can put in structured, semi-structured, unstructured data in there and do that with no code. You just set some configuration and it's ready to go into the system. This is an example of high level what the demo does. I've got a Xavier box over there, got some sensors, it's got a camera, it's doing some deep learning on it, pushes that data over native Pulsar protocol into Pulsar. There's Flink SQL app on it. There's a Spark app, and then I have a sync dropping that to Elastic. I also have other sources of data coming through WebSockets, going out to WebSockets, coming through MQTT. And again, everything is just Pulsar, makes it pretty simple. Let's get into the fun part of the demo. Let's start off at the end of the demo, which is everything's made it into Elastic. I'm running this on my own little in-house Docker. Just a easy way, so easy to set this up in Elastic. So I have some data coming in from my edge system, and I created just a very simple dashboard because that's that's not my expertise, but I like to be able to see, yes, data's coming in, things are changing. That's great. I like to see that. So very easy to just create your visualizations just to see them. And I can take a look at my index, see what documents are coming in, and I could see the format. This is great. I'm just sending in a simple JSON to this index. What's nice is this couldn't be easier. And I'll show you the source code because it's very simple. So I just set up my Elastic and Docker. I set up a sync in Pulsar. This can be done through any DevOps tool you have or through, a Stream Native console or something. But for the sake of keeping it simple, and so you could replicate this in Docker if you want, we just show you the command line interface to do that. Very simple Pulsar admin commands. First up, I make sure I get rid of any old one that I have. Sometimes I got to deploy this a couple times because I can't remember how to spell things. Uh, what can you do? And then I create a new one, grab the archive. This is the latest version of Pulsar. If you got a different version, you use that. This is just a NAR file, is just a jar file with an NiFi extension. I picked my tenant here. This one is public. That's the default one. Obviously, use whatever tenant and namespace you want. And then give it a name. I point it to my config file. And then I put in what topic I want, or multiple topics to go to that sync. Set how many I want it to run, and it's off. And then I can check the status, which I have over here. And I can see that data keeps coming in. I'm running data here. So we're up to 500 messages pushed through. And that's running here from my embedded NVIDIA device, which is grabbing a still image from a camera, doing some deep learning on it using its GPU, putting some metadata and some other data about the system into a JSON file and sending that out. And Pulsar is getting that. And then the sync is dumping that into Elastic. And then we could do whatever analytics we want on that as the data is coming in. Makes it very easy. Now, if I want to visualize that data somewhere else, it's very easy to do. I'm using a very simple single page application here that's just displaying the data from Pulsar. There's no extra database in the way. This is just making a WebSocket call out to Pulsar, subscribing to a topic, and just getting that data out. Again, that's just one of the many ways you can access data without too much problem. It's nighttime over here in sunny New Jersey, so my analytics is telling me that there's a spotlight out there. It's dark out. There probably is a spotlight right out my window, so that's pretty good analytics there. Now, if I wanted to do something else with my data, part of the flip stack is usually NiFi. Hopefully that's loading there. While that's waiting, I'm going to go into Flink. And what this is showing me is a continuous SQL query of all those messages. So when a message is finished here, you'll see it pop down to the bottom. And I can take a look at all the fields in here. And I can do anything I want with the SQL. I'm using the SQL command line interface just to show you SQL on the data as it's coming in continuously. If you look, I have 50 pages of data here as the data has been coming in, and I subscribe to it since the first one. This could be 50 million pages, something to think about. My tables here are pretty straightforward. I'm using a catalog, and it'll give me access to every topic in the system as a table. So I could show here my very imaginatively named topic here, IoT, and Jetson, where it's coming from in the format. And you see the different fields here. This is the results of the deep learning. That's a percent, couple of values based on the system characteristics. And I just send them over. And I could just select a couple of fields. What's nice with this SQL in Flink is I can have this insert into another topic, and that topic could be a different sync. Or I could use Flink's connectors to store that to a different database, to store it to HDFS, put it in S3, send it to another system, send it to Kafka. You know, lots of different things you could do. Pretty straightforward without a lot of heavy lifting here. And this is standard SQL, nothing very complex. And I also, at the same time, on that same topic, I have a Spark structured streaming SQL app here, again, from the command line to keep it easy. This could also be as a part of a continuous ETL, sending that somewhere else, or doing some of that Spark magic on it, maybe putting some machine learning, whatever you want there. So I've got those two continuous SQL queries running as data is coming in. Pretty straightforward. And I could go to NiFi Didn't time out here. Security is great unless you want to use something. I also have administration. If I want to see what's going on with my cluster, I can look through all the different tenants, look through all the namespaces, very easy to navigate these things. Then look through all my topics. Like here is that Jetson JSON one. I could see everything going on with that, see the storage. Pretty straightforward. I can see all the different readers reading it. And you can see here how many have gone through the different positions in the data. Pretty straightforward. NiFi doesn't want to run today. What are you going to do? I could do the same thing within Stream Native Cloud, but that'll also show me very easily the schema. And this schema was created automatically for me by building a Java object, and then I just drop it in. If you look at the demo, pretty easy for you to replicate this. Give you access to the table. Again, you could create the table from scratch with a create table statement, or just let the Pulsar catalog give you all those tables for you, as long as you have a schema. Otherwise, you're just going to have one value there. Not very exciting then. But we have that data coming in, getting pushed out. Really easy to do that with NiFi. We're getting low on time. So just give you a little more information. Some common use cases. We mentioned the unified messaging. Ad tech works out really well for something like Pulsar. So does fraud detection, especially connected to Flink and using those Pulsar functions. As we showed for Elastic, great place to buffer the data, even if it's hundreds of petabytes of data. IoT, very easy to do here. We have an ambassador program. If you're interested in Pulsar, we'd like to help you out there. We've got a survey. Be great if you could take the survey, help us know what to do next with Pulsar. If you want to learn more, we have a free on-demand training. Includes Docker containers you can log into and run some applications on. And we've got live virtual training pretty soon. I think that's next week. I think there may be a spot left. Sign up today. If you like the stuff I talk about, I do a weekly newsletter for Flipstack. So just sign up. Elasticsearch is in there. Whatever cool new things out, I try to put it in there. Articles, code, videos, slides, what have you. If you liked my talk, get in touch. If you didn't like my talk, get in touch with someone else. My connection info is there. I think we're pretty close to time here. But if there's any questions, I'm not sure how you can reach me, but those are good.